Finally, something easy. I'm going to try to refrain from saying the same thing over again, but I know I have for like every time I show you template, I tell you, this is the, I'm going to try to pull back from that. Because you can use the code that I give you in order to kind of prove that as well. As a matter of fact, I'm going to show you some results here in a moment. In pushback, you remember it's going to just put a new item at the end of the vector. Now remember, that's where the size of and capacity comes into play here. So that's why you see size of being, well, used. There's that equal sign, and we just went over a lot about the equal sign. So this one happens to be worrying about one item and not about an entire vector. So that equal sign would be using either integer, in our particular cases, or student. And it would copy it into that array of that size of, whatever the value is there. And hopefully we've got enough space. If we don't have enough space, there's our increased capacity, which you're going to see here in a moment, but that's really familiar. So that's the good news when it comes to that as well. How we're using it? We're using it just like you saw in our overall set of using STL vectors. There's nothing crazy about it, pushing our integer values into our int array or pushing new student values into our classroom one. By the way, there's many ways of doing this. This is frankly probably a lazy way of doing this, but it works out just fine. You could create your own variables of students first, put the values in, and then put the variable in. Fine, whatever. This works too. How can I display the results? I'm going to show you that in a second, is again, doing the overloaded cout that I created in the code that I gave you. Again, didn't come by nature. I had to create this one. And using our couts for our int array and classroom. And let me show you what that looks like. Here's the results using the overloaded cout. Now, by the way, remember, the overloaded cout, you are the one who actually is in charge of how it physically looks on the screen. You are. I was the one that put the, % sign in between each of my students that are in this particular vector. Remember, I had it set to 5. The first 3 were, first 2 were sets new students, and then it did the 100s, 99, 98 on the previous page here. So that's what that, I set this all up. The data was all set up. How it looks is all set up by me. And you'll notice at the very top here, I say what the size is, see if it's empty, and then here are the values that are in there. Now, by the way, that looks pretty similar to what we have for integers, right? So notice my overloaded cout is going to display size is empty, and then here are the values in between. Well, they look exactly the same, don't they? And they should, at least pretty close. Now, the objects that are in there, this is for an integer, and this is obviously for a student, are going to look different, but guess what? They're going to use the couts for their respective data types. Integer, remember cout, the old cout? That works just fine. With student, I bet you I have an overloaded cout for student somewhere. I do. So that's why the results look like the way that they are, because I overloaded cout for student. I didn't need to overload the cout for integer because it's a basic data type, but still. That's the results that we have for so far and all of the items that we've done so far.